The topic in this session is fiber optic cables. We know that in any practical application, fibers need to be incorporated in some type of cable structures. The major components of an optical cable include primary and secondary buffer coating of the fiber. Also, a suitable strength material for the core of the cable is needed, and additional strength materials in the form of steel wires or organic strength materials, water blocking materials and sheath materials are additional requirements. And the primary coating protects the fiber from mechanical shock during manufacturing, and the secondary coating protects the fiber from installation and operational hazards. The two basic fiber optic cable structures are, first one is tight buffered fiber cable design and the second is loose tube cable configuration. And besides that, there is another configuration, that is ribbon cable. And let us go to the details of each one. The tight buffered fibers are used for indoor applications and loose tube structures are used for long haul outdoor applications. And the ribbon cable is the tight buffered structure itself, but it is an extension of the tight buffered cable. In all these cases, fibers consisting of normally the glass core and the cladding, and both the cladding and core are made up of glass. But for the core, refractive index is higher than that of the cladding refractive index. And these two structures are surrounded by a 250 micrometer diameter coating. You can see it in the figure. See here, at the center it is a glass fiber with the cladding, and it is then covered with a fiber coating of 250 micrometer. Okay. After that, there is a fiber buffer and its diameter is 900 micrometer, and the fiber buffer is water resistant material. It absorbs, it prevents the moisture getting into the fiber core, and above all this fiber buffer there is a strength material, and all these structures is encapsulated in a cable jacket. So tight buffered buffer cable is shown in the figure, and each fiber is encapsulated within 900 micrometer plastic buffer structure. So it is, since it is tightly coated, so it got the name tight buffered design. Also, in a single fiber tight buffered module, that means in the fiber there is only single fiber will be there. The cable, there is only one single fiber will be there, and in that case a layer of aramid strength material surrounds the 900 micrometer fiber structure. You can see it in the figure that it is shown that above the buffer structure there is a yarn, aramid yarn strength member, and this configuration is then encapsulated within a PVC outer jacket. And this is the case of a tight buffer structure. And in the case of loose tube cable configuration, one or more standard coated fibers are enclosed in a thermoplastic tube. That means there will be more than one fibers that are enclosed in a tube, and that are thermoplastic tube. And the fibers in the tube are slightly longer than the cable. That means fibers inside the tube is slightly longer than that of the tube, and this is provided in order to avoid the stretching of fiber due to the changes in the structure of the cable. And this tube is filled with gel or dry water, dry water that act as a buffer, and the buffers enables the fibers to move freely within the tube and prevent moisture from entering the tube. You can see the figure, and in the figure 1 it shows that different fibers are loose packed within the tube, and in loose packing within the tuber groover, the primary coated fibers are loosely placed in a hard outer tube, and that is shown in the figure A. And sometimes the primary coated fibers are laid in V-grooved cylinder core that is surrounded by outer tube, and it is shown in the figure B. Here fibers are placed within the V-grooved structure. You can see here. See, fibers are placed within the V-grooved structure, and it shows that primary coated fiber is within the V-groove structure, and the outermost covering is the PVC tape belt, and the strength material is there. Also the plastic core is shown. So single primary or secondary coated fibers are used for plant application. That means in the case of simple plant application, single fibers that are primary and secondary coated are used. But for field applications, large number of primary or secondary coated buffers are generally placed around a central strength materials, and that are fastened by a plastic tape surrounded by outer jacket. So for plant applications, this type of fiber is used, that is single fiber is coated in primary coating is there, and secondary coating is there. And but in the case of field applications, more than one fibers are encapsulated within the coating, and such an arrangement is shown in the figure. You can see that it gives a assembly of 7 fibers. You can count the number of fibers here, that is 1 2 3 4 5 6 7. 7 fibers are there, and also in between the fibers, coated fibers, primary and secondary coated fibers, a dot point is shown there. That means here the dot point 1 2 3 etc. are shown, that indicates the insulated conductor, and these all structures are surrounded by plastic tape, and this inside of the plastic tape it is filled with buffer, and above all there is a yarn or strength material, and there is an outer sheath also. So an assembly of 7 buffer coated fiber is shown in the figure, and that is strengthened by incorporating an organic strength material, and that is then covered in a outer jacket. And here there are 7 fibers are there, and these fibers are arranged around the strength material, and central strength material is also shown. And the fiber cable also shows additional insulated copper wires, and that adds strength to the cable. Also these copper wires may be used to supply power to inline equipment such as repeaters or amplifiers like that, and the outer sheath protects the fiber from certain abrasions. You can see that there are metal conductors provided inside the plastic sheath. You can see it is represented like the dots, and these are used for providing power to inline equipment such as repeaters. And but 2 or more plastic jackets are not adequate to provide protection against penetration of water in the fiber in the case of submarine applications. So for water protection, additional measures such as racially laid aluminum foil or polyethylene laminated film on the inner side of the sheath is incorporated in the fiber. So to facilitate field operation, sometimes ribbon cable arrangement is used. You can see the ribbon cable arrangement, and here a number of fibers in the ribbon typically ranges from 4 to 12, and the fibers are arranged next to each other and are encapsulated in a plastic buffer or jacket to form a long continuous ribbon. You can see that different fibers are arranged next to each other, and they are encapsulated in a plastic buffer, and it forms the shape of a long ribbon. And these ribbons, once the ribbon is formed, and these ribbons can be stacked on the top of each other to form a densely packed arrangement, so that a large number of fibers within the cable structure is obtained. So each fiber is shown here, and that are coated fibers, that is primary and secondary coated fibers, and that has a diameter of 250 micrometer, and plastic encapsulation is also shown in the figure. Next is the indoor cable designs. We know that indoor cables can be used for interconnecting instruments, for distributing signals among the office users, for connections to printers or servers, and for short patch cords in telecommunication equipment racks. And the three main types of indoor cable designs are interconnect cable is the first one, and second is the breakout or fan out cable, and third one is the distribution cable. First is the interconnect cable, and this cable is used for indoor applications such as fiber to the desk links, point to point run in conduit and tray, and patch cords. Patch cords are also known as jumper cables, and they are short length cables, and usually that is less than 2 meter. And patch cords are simplex or duplex cables, and that has connectors on both ends, and patch cords used to interconnect optical transmission modules within an equipment rack. So the cable is flexible, and this type of interconnect cable which is used for indoor applications, and these cables are flexible, compact and lightweight, and that is a light buffered construction. And the popular indoor cable type is the duplex cable, and it consists of two fibers that are encapsulated in an outer PVC jacket. In the case of duplex cable, there will be two fibers within it. Okay. And next is the breakout or fan out cable, and it consists of up to 12 buffered fibers, and that is stranded around a central strength member. And breakout cable allows the easy installation of connectors on individual fibers in the cable, so that it can be connected to other modules. And next is the distribution cable, and that consists of individual or small groupings of light buffered fibers, and that is stranded around this central strength member. And these cables are used for sending data, voice, and video signals. And these are designed to use in intra-building cable trays and conduits. And here the loose cables are loose placed, and the main feature is that they enable the group. In this case, that is for indoor application. The cables are tightly spaced. The fibers are tightly spaced within the cable. And also the main feature is that this type of distribution cables enable grouping of fibers within the cable, and that can be branched to various locations according to our need. Next is outdoor cables, and the outdoor cable installation include aerial, duct, direct burial, and underwater applications. And loose tube structure fibers are used in the case of outdoor applications. And there are three types of cables, that is aerial cable, armored cable, and underwater cable or submarine cable. And first one is the aerial cable, and that is intended for mounting outside between buildings or on poles or towers. In this two structures are there, that is self-supporting structure and a facility supporting structure. In the case of self-supporting structure, it contains an internal strength member, and there is no additional support mechanisms. That means the aerial cable is supported between the two poles without any other supporting mechanisms. And in the case of facility supporting mechanism, the cable is has a separate wire for supporting. That means once that first the wire, that additional wire will be mounted between the poles, and then this cable is clipped into that wire. So next type is the armored cable, and for direct burial or underground duct applications, we incorporate one or more layer of steel wire protective armoring below the layer of polyethylene jacket, and that is for additional protection in the case of underground duct, and it provides additional strength, and also it protects the fiber from gnawing animals. And the armored cable structure is shown in the figure, and you can see that it is arranged in a loose type manner. There are 6 fibers and that are arranged loosely around a central strength member, and that represents a loose tube structure. And there is a buffer element, that is water blocking compound, and above all there is a tap, that is wrapping and binding tap, and after that there is a inner polyethylene jacket to provide protection, and after that there is a corrugated steel tape, and that protect the fiber from gnawing elements, and outside that there is a polyethylene jacket. This is the structure of armored cable. And next is a submarine cable or underwater cable, and that are exposed to high water pressure, that may be submerged in the river or in sea, and these cables have various water blocking layers, one or more protective inner polyethylene sheets, and a heavy outer armor jacket, and cables that run under the ocean have further layers of armoring and containing copper wires to provide electrical power for submerged optical amplifiers or regenerators, and the structure of submerged cable is shown in the figure. You can see that at the center there is a strength member, and the fiber or loose tube structure is arranged here, that is 6 fibers are shown, and they are loosely arranged, and there is a water blocking filling compound, that is a gel, and these are encapsulated in a tape or wrapping tape and moisture barrier, and after that there is a polyethylene inner sheet, and then it is surrounded by a lead sheath, and there is a second layer of polyethylene central sheath, and also there is a bedding layer, and that is made up of yarn or astal, and there is a galvanized steel wire armoring, and these all are encapsulated in a protective sheath. This is the structure of a submarine cables, and more protective sheath is needed in this case. This is all about fiber cable structures.